Okay, let's dive right into this. You know, when you hold a smartphone in your hand, you are quite literally holding more computing power than the entire Apollo mission used to go to the moon. Crazy, right? Naturally, you're probably just thinking about the apps, the camera quality, or maybe just how sleek the design is. But underneath that shiny glass and metal exterior, well, that is one of the most fiercely contested battlegrounds in modern technology. It's not just a consumer device. It's a highly complex, meticulously engineered ecosystem of semiconductor components. So today, we're going to unpack the smartphone internal architecture and its operation principles. We're going to break down the hardware, trace the exact operation flow, and most importantly, map all of this back to the market influence of key supply chain vendors. Welcome to this Masterclass Explainer. Now, you might assume a hardware masterclass like this is only for hardcore electrical engineers, but honestly, that couldn't be further from the truth. This is a highly targeted learning path designed specifically for professionals in product marketing, supply chain, procurement, business development, and really anyone just stepping foot into the semiconductor industry. And why is that? Because you simply cannot fully grasp the market value of these components or negotiate effectively if you don't actually understand how the hardware operates. We are going to directly tie this technical architecture to strategic influence and market value, giving you a very distinct professional edge and an expert analytical perspective on the global supply chain. So, here is our roadmap for today. First, the core architecture beginner guide. Second, the core brain, focusing on the SoC and memory. Third, vision and power operation flow. Fourth, communication and packaging. And finally, fifth, key vendor market influence. Don't worry if you're a complete beginner. We are going to break all of this down logically. All right, Section 1, the Core Architecture Beginner's Guide. Let's set the foundation. Our source material actually divides this masterclass into 8 distinct modules, which we can neatly group into these 4 chronological steps. It really helps to think of it like building a human body, kind of mapping the operation flow from head to toe. Step 1 is the brain and the general nervous system. Step 2, that's your short-term memory and the heart, pumping blood, or in this case, power to the rest of the body. Step 3 represents the senses, so how the phone actually takes in light through the camera and outputs visuals back to you through the display. And finally, step 4 is the ability to speak and hear via 5G, along with the physical skeleton, the PCB and packaging that literally holds the whole shebang together. And this is a great way to illustrate the learning curve you can expect here. We've got Module 1, the system overview, sitting at a very approachable 1-star difficulty. It's just the high-level map. But as we get deeper into how these chips are physically integrated, the complexity ramps up fast. By the time we hit Module 8, looking at printed circuit boards, advanced packaging, and silicon capacitors, we are hitting a solid 4-star difficulty. It's highly complex engineering, but we're going to scale this mountain step by step, taking you from that simple 1-star novice overview right up to the doorstep of 4-star structural engineering. Moving right along to Section 2, the core brain, SoC, and memory. Okay, so the absolute most crucial point here is understanding the SoC, or the system on chip. In the smartphone world, you'll usually hear this called the application processor. When we talk about major technical breakthroughs in SoC architecture, well, this is where the magic happens. We're talking about billions of microscopic transistors packed tightly into this tiny piece of silicon, dictating the entire hardware operation logic of the device. The SoC isn't just one single processor. It is exactly what the name says, an entire system on a single chip. It combines the CPU, the GPU for your graphics, the NPU for artificial intelligence, all of it into one tiny, incredibly powerful command center.
But let's be real, a brain is completely useless if it can't remember anything, right? And that brings us to Module 3, which pairs perfectly with the SoC. Both of these are rated at a very manageable 2-star difficulty. You see, once the application processor calculates all that data, it intimately relies on the memory modules to actually function. You've got your DRAM, which acts as the super-fast, short-term workspace the SoC uses while your apps are running. Then you have the NAND flash memory. That's your long-term storage where your photos, your operating system, and your apps permanently live. The continuous, lightning-fast operation flow between the SoC and this memory is exactly what makes your phone feel so fast and responsive.
Next up, Section 3, the vision and power operation flow. Let's look at Module 4, the PMIC, or Power Management Integrated Circuit. Now, we jump up to a 3-star difficulty here, and for very good reason. If the SoC is the brain, the PMIC is absolutely the heart of the smartphone. Think about it. The battery provides raw power, sure, but different chips need wildly different voltages at different times. The PMIC dynamically delivers exactly the right amount of power to the exact right component at precisely the right millisecond.
It's incredibly complex. Without the PMIC managing this operation flow, your phone would literally melt in your hand, or at best, drain its battery in about 5 minutes flat.
And that dynamic input-output relationship brings us to modules 5 and 6. On one side, we have the camera imaging pipeline. This is how the phone physically captures external light, converts it into digital data, and sends it straight to the SoC to be processed. On the flip side, we have the display and touch system. This is how the SoC takes that processed data and outputs it back out into the physical world so you can actually see it and interact with it. Both of these are foundational two-star concepts, but mastering exactly how these peripheral systems communicate with the core brain is just absolutely vital for anyone in product marketing or supply chain.
All right, section 4, the communication module and underlying packaging. Let's talk about module 7, the 5G modem and the RF, or radio frequency front end. This is a 3-star difficulty module that handles the critical signal journey. Just think about this for a second. Invisible radio waves travel through the air, get captured by your phone's antenna, are filtered and amplified by the RF front end, and then get translated into digital data by the 5G modem just so the SoC can understand it. It is a wildly intricate dance of analog and digital signals. For supply chain professionals, this is an area of massive strategic importance, simply because the components required here are incredibly specialized.
Which brings us to the most complex part of our entire masterclass, Module 8, coming in at a heavy 4-star difficulty, the underlying packaging. Once you have your SoC, your memory, your PMIC, and your 5G modem, well, they can't just float in space. They have to be physically integrated. The printed circuit board, or PCB, is essentially the multi-layered highway system that physically connects every single chip. Advanced packaging techniques allow manufacturers to actually stack chips right on top of each other to save space, while silicon capacitors manage tiny power fluctuations. This is the structural engineering foundation of the phone, and mastering this gives you incredibly deep insight into manufacturing bottlenecks. Finally, Section 5, Supply Chain Key Player Influence. This is where it all comes together. I want to highlight this quote directly from our source material because it really represents the core philosophy of this whole explainer. Understand not only what each chip does, but also how they interact and why these specific companies are strategically important. You see, knowing the hardware architecture is literally only half the battle. The real value for procurement, business development, and market analysis is understanding who actually makes these chips. When you understand the technical difficulty of a component, you immediately understand the immense market value and leverage held by the vendor who successfully manufactures it.
So let's see how this builds into a practical framework. We can explicitly link the architecture we just learned to real-world market influence. When we talk about the core brain, that SoC, the dominant strategic players are Qualcomm and MediaTek. Understanding their competitiveness dictates everything in procurement. For camera imaging pipelines, Sony holds massive influence over the sensors. When it comes to displays, Samsung is an absolute giant in the panels themselves, while companies like Novatech are highly critical for the display driver ICs. And the PMIC suppliers? They're the unsung heroes keeping the power flowing. By mapping the architecture to these vendors, you suddenly see the smartphone not just as a single product, but as an assembled puzzle of global corporate leverage.
So we've walked through the SoC brain, the power delivery, the signal journey, and the key vendors holding the keys to the kingdom. I want to leave you with this final thought. As you look at this incredibly complex, highly interdependent ecosystem, which of these crucial supply chain components represents the biggest vulnerability and the biggest opportunity for the future of mobile architecture? Whether you're in procurement trying to secure supply or product marketing trying to sell the next big breakthrough, mastering this internal architecture is your ultimate strategic edge. Keep diving into these modules, keep questioning the supply chain, and I'll see you in the next explainer.